Hello everyone, welcome to the fifth part of this video series. In this video, we are going to discuss how we can select the right AP or antenna for the environment we're designing for. Also, we will use Ekahau Auto Planner design tool in order to produce the first design. Let's get started. So this is the layout that we imported together using WOW feature. It contains the coverage areas that we have defined, as well as the exclusion areas. Let's hide them. Also, walls are there. Let's hide them. Now, before we start our design, we need to decide about the right access point or antenna to be used. By the type of the antenna and access point, I don't refer to any vendor. I just refer to the antenna coverage pattern. So I don't mean Cisco or Aruba, etc. It's all about the coverage pattern, whether it's omni or directional. As you know, we have access points with omnidirectional internal or external antennas. Also, we have access point with directional external antennas. So the question is, which one is the best access point or antenna that will be fit for our environment in terms of both coverage and capacity? In order to find out the answer, we need to move actually to another map view. Okay, let us show the walls, and I'm going to use this layout in order to demonstrate the difference between both omnidirectional and directional antennas. Then we will come into the conclusion together about which one will be the best fit for each coverage areas in our layout. So for that sake, I'm going to select a generic access point. I'm not going to use any access point from any vendor like Aruba, Cisco, Aerohive, etc. So let us place the first access point here and the second access point here. As you can see, as you place your access point in the map, you can see them getting listed here in the access point listing section. Now, this access point will be used as an access point with an internal omnidirectional antenna, and this access point will be modified to use external directional antenna. Let us check the settings of the first access point first. So it is a ceiling mount access point. It will be running on channel 1 and 6 for both bands, and it will be defaulted into the 2.4 meters height. And last but not least, this access point will be using internal generic 2.2 dBi omnidirectional antenna for both bands. Okay, let us check the second access point. Okay, so the access point, we will modify it to be a directional antenna. So I'll stick with all these settings in terms of TX power, channel, height for now. I'll only change the antenna. So what antenna type I could use to demonstrate the difference between omni and directional? Let's go to Google. There is a website. It's called Axel Tex. Yeah, this is the one. They have multiple antenna types that we can select from. So let's go to products. We can select patch or high density patch antennas. We don't want omni. We already have one defined in Ekahau. So let us go with the 4-element antenna. We have these models. So this is 10, 11 dBi gain and 2.4 and 5 gigahertz. This is 13 dBi gain in both bands. So let's stick to this one. This is the part number of the antenna model. Let us copy that. And actually, I would expect to find it in Ekahau. So if I paste, I can select this antenna to be used with this access point. Let us do the same on 5 gigahertz. Now, the access point is wall mounted. Let us see the coverage pattern before I change it into ceiling mount. As you can see, the coverage pattern produced this shape. This is on 5 gigahertz. Let us check 2.4. Let us check both. Now, let us mount this on the ceiling. Okay, so now both access points are using the same settings in terms of TX power, channels, and the height. The only difference is the antenna. Now, in order to try to demonstrate the difference between them, the only thing we can play with will be the height. So now we can see the coverage pattern from both access points on 2.4 meters height. Let us try to raise that. Let us select this access point and this access point. Edit multiple access points. Let us use 3 meters. Coverage pattern for omnidirectional antenna didn't change, but it got maximized or increased a little bit for the directional antenna. Let us double the height for now. Okay, we have applied that. Strange. For the omnidirectional access point, we see a corrupted coverage pattern actually, because now the access point is able to provide or meet the signal's requirement in this location, while it cannot do that for the users below it. It's not the case for the directional antenna access point. Okay, before we come to the conclusion, let us raise it again. Let's use 10 meters. We have applied that. That's strange. We can see that as we raise the omnidirectional access point, the signal on the ground doesn't meet the requirement. And it is the other way around for the directional antenna. Basically, directional antennas focus the transmission in a certain direction. So I don't expect to see any corrupted coverage as we have seen here. Let us check the 2.4 coverage. It's the same case. Okay, now the conclusion here, we could actually use any access point or antenna model in environments with low ceiling height, whereas we can only use directional antennas in environment with ceiling height higher than or equal 4 or 5 meters. That is a good conclusion. Now, let us get back to our design. Actually, one last thing I just remembered before we move on. We have to really explain why do we design using the NIC 57 while our original signal strength and coverage requirements was NIC 67. Well, again, in order to show this, we need to get back to the previous layout. Before I do that, let's select the 2-axis point and maybe modify the height for now. Okay, so basically, in any environment that you're designing for, you would expect to have a mix of WLAN client devices. Each one of these devices has its own RX, receive sensitivity, which is receiver sensitivity. Now, just as simple as it is, without going into the theory behind the RX receive sensitivity, let's try to imagine what it is. Basically, if you have two mobile devices placed in a certain location, in the same location, on an equal distance away from the access point, then both of them will be able to perceive different RF signal strength for the received signal. What does that mean? Let me try to explain this for you. So I remember I have placed a note here denoting the two devices. So assume we have a laptop with Intel wireless card here and an Android device placed here. They are of the same equal distance away from this access point. And before we continue, let's raise this to our original coverage requirements. Basically, these devices are on the same location and of the same distance away from the access point. The RX receive sensitivity means that this laptop, the Intel wireless card, will be able to receive the signal strength for the signals coming from this access point using, for example, let's see what is the RX value here. It's NIG67, which is the edge of our cell. Unfortunately, this mobile device will not receive the signal on the same actually signal strength. Even it is showing that here in our view. Now, in order to demonstrate this, let us consider this one as a generic laptop and this one as just a BYOD device. You remember, this is generic laptop and the other one would be a BYOD device. Now, if we go to this view, if we select a generic device, you see the coverage pattern got changed. If we put the mouse here, we will be able to read the signal strength as NIC 70. So this means that the laptop will be able to receive the signal coming from the access point with signal strength of NIC 70. Let's change that into the BYOD device. That got reduced also. Let's try to click on the same location. You see the difference? This mobile device is able to receive the same RF signal in the same location from the same distance from the access point on a different signal strength value. So this is something you don't have control about. It's about the manufacturer. The manufacturing process of the antenna itself inside each device. Unfortunately, you have to consider these, let's say, receive sensitivity variations in your WLAN design. How can we do this? It's simple. You need to select your least capable device that you are going to support and use it as a reference. Now, how can we do this in predictive surveys in Ekahau? It is actually simple. We can go to project and then to device profiles where we can see all listed devices. You need to go through all the devices that you are going to support over WLAN. Let us assume that we will support all of these devices in our concert hall, just as an assumption. Let's go into one by one. For the generic laptop, it has a -3 dB of offset in both bands. BYOD devices, we define that to be -10 dBs. Generic smartphone, the same values. Generic barcode scanner, the same value. Generic tablet, different value of -5 dB. Generic VoIP phones, -10 dB. So what is the lowest value that we encountered here? It's -10 dB. So we have to use this in our design. The rule of thumb here is that the least capable device will have the least offset value. So in order to consider that in our design, we have to do a quick summation or a simple math. We originally wanted to design for NIG 67 minus NIG 10 dB. This will equal NIG 67 plus 10 dB, which will result into NIG 57. So we have to modify our coverage requirements from the NIG 67 into NIG 57. Now let's get back to our original layout and start designing. Before we start, let's clear the access points from the other layout. We no longer need them. In order to design Wi-Fi for our facility, we are going to use the Auto Planner tool. You can run this tool by going into Project, then Auto Planner, or by simply clicking on this icon. This is the Auto Planner tool. As you can see, the three areas that we have previously defined exist here, along with the capacity forecast per area. You can choose whether to consider this capacity forecast or exclude it. Let's have it included in our plan. The next thing that you need to provide as an input for this planner tool is the access point, the model that you are going to use. Actually, I'm going to use a Cisco access point. So let us see what are the latest access points available from Cisco. Access points, yes. So we have 4 available models that support 82.11ax or Wi-Fi 6 access points. Now I'm going to select the 9120 access point. Let's go into that. We need to go into the datasheet of this access point. Okay, so before we feed anything into the planner, let's view the area. Now, as we agreed, we will use access point with internal antenna in this area, and the same case will be applied here. But for this area, we will use an external antenna model. Let us see in the datasheet what we have. So if we type external antenna, External antennas. Okay, we have, I can see this option. Actually, the specification of this, I think, can be found on the internet, but yeah, I can see this one has 13 dBi gain for both 2.4 and 5 gigahertz. This is similar to the one that we already used from Axel Tix, if you remember. So let's try to use this. Now, in the Auto Planner, you can only choose only one access point, actually. You can define two access point models. So what I'm going to do, I'm going to select the Auto Planner, or I'm going to ask the Auto Planner to run using the internal antennas, using the internal antenna model of this access point, the 9120, and then we will modify that together. So let's rerun the access point that I'm going to select. It's Catalyst 9120i. Since we have a high density area, actually, I'm going to lower the power for now. So let's start with 2 dBm and 8 dBm at the 5 gigahertz. For the advanced settings, you can use the default, but it's always recommended to actually select the options that fit your environment. So for our height, we have two types of ceiling heights. One as 3 and the other in the hole, it's around 10 meters. Let's start with 3, and again, we will modify the height value for the concert hall. The channels, I'll stick with this plan. For the 5 gigahertz, you need to select the ones needed for your country that you're designing for. But for the sake of this demo, I'll also use all the channels for now. You can choose whether to design using dual 5 gigahertz access points. Let's exclude that for now. You can define the minimum data rates and band steering. Let's have it disabled. We will design as if we are going to have two SSIDs broadcasted in that area. So let's run this magic tool. You can see here all requirements couldn't be met. Please review the requirements and design. We will check that together. Now, how many access points? Actually, this planner tool initially detected or predicted, for our layout. Let's remove the area and let's remove the walls. Actually, let us remove everything except the radios of the antennas. Okay. As you can see, we have around, let's run the statistics. We have around 52 plus 40, 92, 93, 90, around 95% of our areas, as per the coloring scheme used in the legend, are meeting the requirements. I mean the signal strength requirements. So that's good. This tool actually could provide a good forecast for the number of access points. You still actually have to look into each access point placement and modify as needed. For example, if you remember, let's get back to the walls. The planner has placed an access point in an area where no one actually can be available there or can go there. So you still need to go and do your magic in order to move the access point. It's good idea to rely actually or to start with the Auto Planner tool. But again, in terms of AP placement, Wi-Fi engineers have better, let's say, human touch in terms of AP placements. So please, if you're going to use this, that's fine, but don't rely 100% on that. Consider 75% of what actually the Auto Planner does to your environment. Then you need to modify as needed. Just before we wrap up this video, we said, let's clear everything first. We said we want actually to modify the height and the antenna types for the access points inside the concert hall. Let's do this by editing multiple simulated access points. And okay, why is this selection not available? Just a minute, what's going on? Okay, why is that? For the others, let's see. Edit multiple access points. It's still there. What? Let's see what's going on. Maybe something wrong with Ekahau. Okay. We are going to use 9120 with this access point or antenna model. It is 2513P4M. Let's select that again. Yeah, this is it. Okay, we need to change. Okay, I think these got changed. So let's put 2 and 8 for now. Okay, so we have changed the model of our access points inside the concert hall. Let's see the coverage again. Just to make sure, do we have the access point ceiling mount? Okay, that's right. So based on this coverage, we have around 67, 87, 90, 93 after we changed the access point model from internal to external. We have around 93% of our areas inside the layout that meet our minimum signal requirements. So that is the design that you can think of when you actually run the Auto Planner. That's it. That wraps up our video for this part of this series. Thank you for watching.